All right. So as some folks mentioned and brought up yesterday, energy infrastructure, particularly nuclear projects, are highly constrained by supply chain challenges. And today, our first panel will examine some of these challenges and opportunities for improvement. I will turn it over to the panelists to introduce themselves, and then we'll get into the questions. Start with Drew.
Mic check. Okay, great. Drew DeWalt with General Matter. Our mission is to restore U.S. leadership in enrichment. For the purpose of restoring U.S. leadership in commercial nuclear energy, we think that's the best driver for growth of electrical capacity in the United States and therefore growth in the United States. As we think about supply chain challenges, it's multifaceted. There's a panel later about the fuel cycle space, which we're obviously in the middle of, which is, I think being solved, a lot of support from INL, the NRC, the DOE, but there's a lot of other challenges, and we put them into buckets of, speed and cost effectiveness around access to power, permitting, people, and then obviously the other stuff around, valves, pipes, pumps, all sorts of certs like that. So there's a lot of issues to solve everywhere. I think it can be daunting at times, but it's one of those where if you believe nuclear is the future, it's one foot in front of the other, and we can solve this, I think, in concert with all the players on this panel and everybody out here in the audience. So excited to be here.
Hi, I'm Bill Abolt with Deloitte. We're focused on modernization of the grid from generation through transmission and distribution, and all the steps from permitting reform to digitization of the grid to supply chain reform that will get us there. When we talk about the discussion today about specific to nuclear, I want to just put it in the broader context of the supply chain challenges for meeting our infrastructure needs for energy broadly. We're significantly constrained in our ability to provide the equipment, the infrastructure, to deliver new generation and reliable and resilient transmission and distribution. And that concern about physical infrastructure is equally felt in the supply of workforce. Two areas of policy that the states and federal government have to be in active partnership on, and that it has to involve both the private sector and the communities that get the benefits of the jobs and the benefits of safely operating facilities.
Good morning. My name is Chris Lohse. I work for Idaho National Laboratory, but more specifically, I work for a small group called the Gateway for Accelerated Innovation in Nuclear, also known as GAIN, because that's a lot of letters to string together. So GAIN, every day we kind of wake up and figure out how do we commercialize these advanced nuclear technologies, and one way we do that is utilize the national lab infrastructure and capabilities that exist here. So if people want to know more about that later, come find me. Happy to talk to you about it. When I think about the nuclear supply chain, we do have an existing supply chain that supports the current fleet, but that's not going to be the full supply chain that's going to help us get to advanced reactors and deploying this future fleet. And one of the reasons is the current fleet is optimized to do what it does now, and so the supply chain is optimized to do what it does as well. So the future fleet's a big opportunity. Everyone talks about huge numbers of gigawatts. There's big dreams and aspirations. You have many companies investing in this space. You have large tech companies. You have utilities. Everyone talks around how they want nuclear in their space. So with all the talk around it, you think, why do we have to talk about the supply chain? Well, the supply chain in nuclear specifically is not like the field of dreams, right? If you build it, they will come. It doesn't work that way. So in supply chain space, it's more like if you build the nuclear fleet, the supply chain will come. So it's kind of like you got to think about the right order of operations there. And so when we talk about single units of a plant don't build a supply chain. You need multiple units, you need multiple orders, you need multiple plants being built to stand up all the infrastructure capabilities and the human capital to bring the supply chain forward. So when I think about investing in the supply chain, how you do that, you also have to think about, do you just want, we have this global supply chain, do you want the global supply chain to support it? If you want a US supply chain, do you still want to stand up the same capabilities that exist on the global scale? Can we compete on that global scale with the US with those same capabilities? Or do you start thinking around, advanced technologies. What is advanced manufacturing? Do you still look at leapfrogging and standing up something different in the US to support a future fleet build where you can maybe compete on a more global scale? So that'll be some fun stuff to talk about today. Thanks for having me.
Matt McVicker, Vice President of Government Relations at Rolls-Royce North America. So I'm excited to talk to this crowd because I may not have to remind folks that Rolls-Royce no longer manufactures the cars. That is, we sold that business to BMW back in the late 90s, and today we are a major engineering and manufacturing company. Our primary segments include the aerospace side, where if you get on a plane and there's more than one aisle, more likely than not, that's a Rolls-Royce jet engine powering that plane. So, you know, your Delta A350s, the new one flying out of Salt Lake to Korea, right, powered by Rolls-Royce. We have a defense business as well. So that includes both military jet aircraft, but also some unique capabilities out of a group called Liberty Works, which, if you're familiar with Lockheed Martin Skunk Works, kind of secret aircraft programs, the turbo machinery that marries to those aircraft, we produce in Indianapolis, Indiana. And part of that capability in the turbo machinery space also has a nuclear applicability. And so we are partnered, for instance, with BWXT on Project Pele. In this neck of the woods, Project Pele will be the first Gen 4 reactor delivered to INL, hopefully in the next 24 months, and it'll go to test in the next 24 months. So it's a DoD program delivering a microreactor that can be chopped up into 4 shipping containers. Really, really exciting. And then we have a power systems business as well. Rolls-Royce bought Detroit Diesel's off-highway business. So we actually today make big diesel engines, reciprocating engines. We power the US Coast Guard fleet, but also we are the emergency standby power units under our MTU brand for about a third of the country's data centers. Lastly, though, and really our kind of secret business is nuclear. And Rolls-Royce has been in nuclear for more than 60 years. It started in the 50s through what's called the UK-US Mutual Defense Agreement. This is the agreement that gave the UK nuclear weapons. And as part of that exchange, the UK gave the US noise dampening technology for our submarines, and the US gave the UK the first generation nuclear reactor technology to go and build submarines. And the Eisenhower administration selected Rolls-Royce to be the inheritor and steward of that technology. So for the last 60 years, we've been building little PWRs, compact PWRs, that can be operated underwater by teenagers. And we have an active production line in the UK, and we'll be continuing that line going forward with the SSN AUKUS class, which is the joint ship between the US, UK, and Australia. And out of that business, we've also launched, using that expertise, a small modular reactor business. So we, Rolls-Royce, have a 470 megawatt SMR. We've been down selected in the UK through the Great British Nuclear Program, and also in Czechia, former Czech Republic, with ČEZ, the national utility there. That combination will lead to between kind of 4 to 6 units, which will get us down a learning curve and start to enhance and build that supply chain in Europe. But really, as we look out towards what is the market of the future, it's here in the United States. So with the US-UK agreement that President Trump signed last week, there's now an accelerated pipeline for Rolls-Royce to enter the NRC process. We're going to be design certified in the UK next year. And that really opens up an opportunity where we are starting to look at where do we build factories to produce this SMR, which is essentially a expanded submarine reactor. We're not reinventing the technology. We are inventing the delivery by really breaking it into Lego brick size truck transportable modules that we're going to build in factories. And so as we look out here in the West, right, tons of opportunity, not only for deployment, but also manufacturing and building a supplier network.
Hello, my name is Stacey Donahue. I am a procurement manager in Westinghouse, focusing on deployment of our AP1000 and AP300 technologies. I focus in procurement of the large structural components that go into those technologies, like the containment vessel and shield building. I don't normally deal in government affairs, so I'm coming with the perspective of the supply chain front lines, you know, speaking with suppliers on daily and weekly basis. We've obviously been expanding our global supply chain for the last several years with the deployment of AP1000s, 6 here in the 6 operating plants, 2 here at Vogel, and we have some in China. There's 14 under construction there, and we have contract for 5 in Europe. But with Westinghouse's commitment to support President Trump's executive order, we're refocusing our efforts on finding suppliers here in the United States that can support this really aggressive timeline that we have for deployment of advanced reactor technology. So we have already over 220 suppliers in this region between Utah, Wyoming, and Idaho, but not all of those suppliers are qualified and certified to manufacture in the nuclear sphere. What we're finding is when we're speaking with suppliers here in the United States, there is a little bit of a reluctance or a hesitation in entering into the nuclear market because it's expensive, it's time consuming, and they want to understand their return on investment if they invest in the quality programs and in training their people and in establishing a nuclear safety culture. So what I hope to learn here and to help facilitate is exploring creative and innovative options on how we can perhaps fund these suppliers earlier, because waiting for the projects to go out and have these suppliers invest is not the most likely success strategy. It can take 18 months to 2 years for a commercial supplier to improve or create a quality program that's good enough to be able to fabricate in the nuclear space. So if we wait for the projects to come and then go approach these suppliers, we're going to be behind the curve.
Cool, thank you. So clearly, pretty diverse set of perspectives on supply chain issues on this panel. And as some of you hit on in your intros, the failures or constraints in the nuclear fuel cycle or for nuclear projects is really the convergence of multiple supply chain failures compounding together. So maybe can you discuss some of these gaps that contribute to the current state of the fuel cycle and some of the other supply chain challenges that you guys mentioned in your intros?
I think a couple of the points were raised, particularly the last point about cost in the marketplace and what it actually takes to build a supply chain, and the need for some strong market signals that are a mix of private investment, but they're also a function of significant public commitment and action. We have to recognize that the vast majority of nuclear power plants built in the United States were built under our old kind of the utility, integrated vertical utilities supported by ratepayers. If our goal is to move towards a more diverse marketplace, we need to recognize and sort out what the private sector needs to take risk on and invest in, what its return will be, and what are the steps that the public sector needs to take to make that happen. And the example of governments investing in anticipation of real development, particularly building the capacity of suppliers to provide quality and safety in the delivery is important. And you can see models of that in other elements of energy around the U.S. as they focused on the solar industry or focused on advancements in the digital grid or in wind. And I think some of those same ideas have to be brought to bear in nuclear, and they need to be led not just by the federal government, but by states with a keen interest in delivering real projects in their within their communities.
So the funny thing when you talk about public investment in a lot of these spaces, I think you also have to think about what's the most fungible component that you're looking for, right? Because like the fuel cycle, we talk about the fuel cycle, right? There's a lot of DOE investment going in the fuel cycle, but enriched uranium is a fungible component. I can give it to anybody, right? I can't give an AP1000 reactor vessel to anybody if you stand up giant manufacturing capabilities. So you have to look at across the spectrum, understand where you can get there. In public investment, you can do stuff like supplier certification efforts, right, to help out there. Those are fairly fungible when you come across there. And in fact, like people like EPRI have looked at trying to pilot, say, what they call a fit for nuclear program, right? Where you can actually take and, bring people in and assess their supplier certification, assess what they do, and then figure out what their gaps would be for nuclear deployment, right? They actually do that in the UK. It's called Fit for Nuclear. EPRI tried to actually pilot it here. Maybe they tried to pilot it too early, because I'd say when they were doing it, they couldn't get anyone to sign up. So why? So the question is why then? Why didn't people want to sign up to go do it? Because basically EPRI was trying to pilot a program where, say, 5 companies come in, people evaluate it, and then they determine what those gaps are and help those companies figure out how to fix them. So I mean, programs like that could be very useful. Maybe there's a lack in delivery. Maybe someone else has to be the actual provider to maybe pilot it. But I mean, those types of things would be very useful for, supplier certification, helping companies get on the way.
That's an interesting point. In recent conversations with suppliers, I think what would be very, very helpful is if we could map what it takes to go from an ISO 9000 program to an NQA1 or an ASME instant program, being able to provide that to the suppliers up front so that they can wrap their heads around what type of investment from a workforce, from a timing perspective, and from a cost perspective. Those would all be really helpful in helping the suppliers understand that their investment will be worth their while.
I think that investment has to not just focus on to get the certification, but to maintain it over time. Because some of the reluctance of suppliers to jump in is not the upfront cost, but the reality of maintaining that in anticipation of work.
Some of you did mention the workforce, human capital, supply chain elements, and we'll have a panel in a little bit talking a little bit more in depth about some of those issues. But I guess from your perspective, what are some of the opportunities or ways that governments or their stakeholders can collaborate to better ensure workforce development opportunities for nuclear projects?
I think from my perspective on workforce, it is the most important thing. It's been said several times yesterday. I just truly believe that there's a lot of talented people that more and more so want to be in this industry, but we have to find pathways to get them in here. I think the color of my comments is that also, if we believe everything we've said yesterday and will say today, there just needs to be a general expansion of ownership of the problems of everybody, in the sense that if there's supplier issues, how am I going to meet them halfway? How am I going to take risks? And not necessarily on the safety front, for sure, but how I'm going to risk capital, how I'm going to risk man hours to start the process, to educate suppliers, to invest in their programs for parts that I need, to invest in human capital programs that may have some state sponsorship, but everybody needs to expand their realm of influence. I mean, yesterday there was a discussion around utilities and Meta and Google can make these big investments, and that's true. But there's still, for both loads and generation, there's huge interconnection issues trying to get on the grid. And so those are things that a municipality or a state can take ownership of. And so I think the biggest thing here is, as Stacy pointed out, there's this super long lead time. So we have to make these investments now, because we're, if Pele's on track and these other programs on track, we're not really getting to commercial scale until late this decade, early next. So we need to be investing in these programs today so that we have the people, the vessels, the parts. And I think if we're waiting for everybody else to do their part to serve my business, it's going to be too long. And so I just think it's an expansion of ownership that I would definitely encourage.
So let me maybe frame this kind of how we're thinking of it. So microreactors like Pele, certainly, I think we'd hope for a really accelerated timeline. I think from the SMR side, these are massive capital infrastructure projects. And when we think about timing, I think it's going to be really difficult to be before 2035 electrons on grid with an SMR. That's just being realistic. And when in our approach, we are building factories that produce the Lego bricks. The Lego bricks get sent to a site, and the entire power plant, not just the reactor, but the turbine island, everything is included in that delivery model. If you're looking at, okay, what does an apprentice look like in 2035? And where are they today? That is your 7th, 8th grade freshman in high school. And you have to frame a track that is delivering the skills, not only for reactor manufacturing and deployment, but also supply chain down to the fuel level and also in your broader supply chain. One of the things we were talking about yesterday was heavy castings and forgings. I mean, I have no idea how you spark a interest in a kid's mind to go into heavy castings and forgings in the United States, especially when we don't have that capacity right now. That's a huge need, and there's a lot that needs to be done there. The other thing that I think from a government policy standpoint where nuclear has a bit of a disadvantage, and this is coming from an aerospace, I was formerly in aerospace, still am a little bit, but the Department of Commerce through the NIST program has a series of manufacturing USA institutes. So these are kind of like tech hubs, but they are essentially rapid prototyping facilities, government-owned, public-private partnership embedded projects within those. But they touch all of the national strategic technology ambitions except for nuclear. So AI has its own manufacturing institute. Lightweighting alloy for US Department of Defense aircraft has like 3. We have biofabrication. We have photovoltaics has its own manufacturing USA institute. And what that allows for is sub-suppliers and small businesses to come in and leverage government equipment to start churning out prototypes, de-risking. They can take designs from reactor companies. They could do that, I guess. But in the aerospace world, they take engine designs. They start understanding, okay, what alloy do we need to make? How do we make it as cheap as possible? And then you have universities that begin to kind of plug in as well and say, okay, we can see where the technical need is going to be in 5 years. So let's start doing coursework so that we can deliver folks right into that pipeline. So, and ask for this room, especially here in the West where there really aren't a lot of these are concentrated elsewhere. Go chase a new manufacturing USA institute for nuclear. Maybe do it at INL, maybe do it in Salt Lake. I think there's an absolute need, and you need a hub to begin to innovate and do rapid prototyping around that is accessible to a lot of these sub-tier suppliers.
I think one of the things you have to do is, kind of, given that time frame, is to invest in the clear thing that we do need. We know that we need a significantly expanded workforce for the modernization and expansion of the grid from generation. And there are a lot of, as was pointed out, there are a lot of comparable skill sets. It was mentioned yesterday. The people that built the last nuclear power plant didn't just stick around and wait for another one. The workforce went where there were jobs. It's pretty well demonstrated that there is a demand for those high-skilled jobs, and we need to prepare for them. At the same time, we look at how to accelerate the market. I mean, if we look at nuclear, you can kind of predict within the next few years what conceivably could be ready, even if we accelerate permitting timeframes. It's dealing with existing capacity, perhaps moving into conversion from old coal plants where you have a lot of infrastructure in place. So you can look at a realistic time frame and plan your jobs for that. But we need more of them.
I mean, one thing's always funny with nuclear. We always talk about we're special. And maybe in nuclear, there is a bit of special aspect, right? But the supply chain, there's people that can build components for other industries can also build components for nuclear power plants. And that's what we have to remember, right? How do we latch on to what's going on overall versus just we need to treat this as our own specific nuclear problem? Because there's more than just the nuclear aspect here that's happening. And the other thing I always, we did supply chain assessment a few years ago before a lot of the demand here and interest has taken off. But when we talk to suppliers, outside of having firm orders so they can make investments, number 2 and number 3 on the list of kind of gaps and challenges was the workforce, right? There was a workforce for them to build components. People then, you have a lot of aging workforce as well. So you have people retiring out, and how do you backfill all that? So that is a thing. I've always said, at some point, if people want to figure out how to make more investment, maybe you need to figure out how to get Micro involved and, get some more PR out there for ourselves, through in Micro's network, because he talks about dirty jobs, he talks about, the skilled trades. They have MicroWorks Foundation. I'm not an investor in it, but I just follow it, and I know he has this thing where they go put scholarships out there for people to go learn trades and then go work in these trades. So stuff like that would be very helpful for nuclear.
I think, and from my perspective, as Chris and Matt both pointed out, there's an opportunity to reskill and upskill for sure. But I think there is a marketing piece for that we can take advantage of right now. Nuclear is of interest. I think our own on-campus recruiting efforts have seen a lot of interest. And I think one of the things is nuclear is so sort of like magic for a lot of folks. And the delta between what you know as a technician, welder, pipe fitter, laborer, being able to do that on a normal job and being able to do that on a nuclear job is actually not that much. There's some nuclear safety, nuclear appreciation. You have some of your workforce needs ANSI certs. You need to appreciate these things. You need to learn some of them, but this is not creating a new worker from scratch. And so, I think focusing on colleges and trade schools is important, but there's also nuclear. I mean, it's just amazing to say that it is a growth industry now. I started out my career in nuclear in the submarine force. I didn't spend some time in it because it didn't feel like a growth industry. It is now. And there are other non-growth industries that we can reskill from as well. And a lot of them are in these Western states. So if you've been working on a mining job site, all these other things, you can get into nuclear without a ton of effort. But you have to have those programs to support them. And I think that's where I like that there's a larger demand signal. There's not just one off-taker for human capital now. There's all these different opportunities. And how do we create the supply side of this equation to feed those industries over time?
One more thing to add, sorry. If at the state level, if there are initiatives like the Admit Utah that are ensuring that students that are graduating from high school are able to enter into a four-year university program, expanding those programs to also allow students to choose a trade school or a technical program or a community college where they can learn either trades or maybe even just the associate's degree that will later feed into a bachelor's degree. I think these are some things that the states can do at the state level that would help encourage our kids who are 7th, 8th, 9th graders entering in high school, understanding that track is available to them, especially if maybe they're not inclined to go and be an engineer. We need those people too, but I think it's a little bit easier for people who are inclined to academically to get scholarships and attend a four-year university. And somehow I love the idea of leveraging micro. That's amazing. It's helping students not feel like they're degraded somehow and moving into a trade. So expanding these initiatives at the state level to make sure students understand that is available to them and that it's a valued skill set in this country is really important.
Awesome. Before I turn it over to audience questions, any closing thoughts from you all? Things we didn't hit on, things you want to mention?
Can I chime in with one just in terms of a call to action for this organization from your states? So what is nuclear going up against? Where are the competition? Shipbuilding. So much momentum nationally towards shipbuilding. And a lot of the skill sets, a lot of the suppliers, are having to choose between the two. So I think we need, both from a state level, but also engage your congressional delegations, engage the White House. Let's get some clarity around nuclear workforce is equal to the need for shipbuilding. Right? Just, the next geopolitical competition is going to be one with electrons just as much as it's going to be cutting waves. The other thing would be to ensure that we don't isolate natural gas. So natural gas in terms of pipeline jobs, in terms of large infrastructure, energy infrastructure development, I think the timing here could work where natural gas isn't going anywhere. It's absolutely going to be a critical part of the American energy future, but there will come a time where we're going to get way more efficient at building natural gas capacity. We've been, exceptional at that of late. Let's make sure that we partner with natural gas to both encourage a joint workforce there. And I think, pipe fitting, welding, skills that they've done excellent in, I think nuclear could absolutely take a front foot and capture some of that.
I think building on this, the idea of partnering, and particularly partnering for the long haul, and the role that states can play in not just bringing business and the private sector to the table, but bringing the community along and being clear about what are the economic opportunities that are associated with energy and with nuclear specifically. What are realistic time frames to achieve them, and what is the mix of investment that has to be made, public and private, to get there? Because I think bringing the public along for the ride and in partnership is what's going to sustain the nuclear market and help it grow over a long period of time. And it's going to take some time.
I have one final point too. If we could think about perhaps expanding funding that's available from the DOE Loan Program Office or from the Defense Production Act, and expand the availability of those funds beyond the developers, but directly to the supply chain, it could help the suppliers. It would de-risk their investment into entering into the nuclear market. So if we could look at creative ways to make that funding available directly to the suppliers, whether it's a tax investment credit at the state level for investing in equipment, workforce, or machinery that we need, so we can move some of these technologies like the ultra large forgings that we can only get in other countries like Korea, and bring that capacity and that technology and that know-how back to the United States, so that when we do go to deploy these projects to this really aggressive timeline, we're able to deliver on time with the proper quality, but also made in America. Because right now, some of the capacity and the technology that we need to do that isn't available here.
So I would say my parting words would be basically don't wait. If you're always waiting for some other piece to come, I think a nuclear future is going to be great for everybody. Everybody will benefit. The real winners, especially on the economic front, are investing now. I'm not going to wait for the human capital supply chain. I'm not going to wait for all the supply chain pieces. I'm investing, risking capital man hours now. If we can create that demand signal from a user side, then the supply signal will come. But that doesn't abdicate the role that states play, because again, states are here in the West are frenemies of sorts, right? Work together but want to win. If you're going to invest in the workforce soon, you're going to get more of this nuclear investment sooner as well. And so I think the people who are willing to move now, to risk hours and capital now, are going to be the big winners. And then the big winners will drive the long tail of future expansion where everybody wins in a nuclear future.
I'm gonna open it up for audience questions. I see a couple hands here.
I'll ask one as I head over to the folks. But one of the things I think I've heard you say is that to a large degree, we don't even have the infrastructure built to supply the chain on some of this stuff, if that made sense. So who has?
Could you explain it a little bit more? I'm not sure it was clear.
We don't have the infrastructure that can supply the stuff that we need to build this stuff out. We may be able to get it from another country.
Not necessarily the expansion that is called for. It's kind of like Chris pointed out. You've got a supply chain that is providing a sustainment of the existing infrastructure. The existing infrastructure is strong. It's operating safely. It's operating reliably. It's reasonable to anticipate that some of the near-term additions, that there is adequate supply chain, that there's a clear enough path to project. The broader expansion that's anticipated, I think, consensus.
That's what I'm talking about.
Yeah, I mean, so and you have to be careful. Depending where you go, right, there's many different reactor technologies, designs out there. So if you're talking structural components, right, a lot of things that go into it, it becomes very reactor specific very quick. Right, you can't build an AP1000 vessel in the U.S. We can't do that, right? That's an easy answer. When it comes to smaller designs, then you're kind of, maybe there's some forgings you can do, but we don't have a there's no vertically integrated companies, right? You basically, someone has to go forge something, and then someone has to go take it to a fabricator and get them to go fabricate it and put it all together. You can do some of the smaller components, but you may still be relying on some international friends as well, for depending on how big your vessels are, steam generators, et cetera.
Yeah. Then who's got the master plan of what all we need where to make all of this work?
That's the multi-billion-dollar question, right?
Yeah.
But I think there are some ideas that came up yesterday that we can think about as we're structuring policy and what we're talking about investment. Ideas like yesterday that were raised around standardization. Every investor wants a certain level of uniqueness. Kind of, we talked about first of its kind of investment, but ultimately, if the stuff is going to be scaled, you're going to need to standardize what can be standardized and look to create some transparency in the marketplace about what's being developed and where there's supply chain gaps, so that the market can in fact respond to it, and that government can look to either incent or require a move towards standardization. That's the only way the stuff's going to scale at a more quick, on a more quick path. I think the other thing from a kind of regulatory standpoint, there's a lot of talk about permitting reform. We really need to look at how the requirements that have generated a lot of safety, but also a lot of process, how those requirements flow down, and whether there are ones that can be taken out or standardized along the way. But standardization is a key idea from yesterday that needs to be brought into the development and the scaling of the market today.
Would you all agree? And I think it was Matt that said, you're thinking 2035 before.
Well, it just depends on how big the project is, right? So you might be able to move a little faster at a smaller scale. You might be able to do a test reactor at a smaller scale. But for a multi-acre structure, Rolls-Royce SMR, AP1000, AP300, where it's like building a stadium. I mean, and even there's also you have a firm lead time on a lot of these parts. You need the contracts. So there's only so much you can accelerate, and then you get all the way down your supply chain to a point where you're talking about minerals flow. And so yeah, being realistic, and the other the approach that one of the things dictating the Rolls-Royce timeline to the U.S. of 2035, let's say, is how our model is shaped. Is when we looked at the challenge set of how do you ensure a level of cost overrun mitigation and guarantee. The only place, hyperscaler funding and PPAs are wonderful here in the US. That is not as good as a state-backed utility in Europe that doesn't have access to cheap natural gas and can't abandon a project saying, we're going to select your design and complete it. So from our standpoint, where we're sitting, where we have, an order book already in Europe, we want to make sure that when we have our first of a kind in the US, as much risk has been chucked out, not on the back of the US taxpayer. And so in order to marry, again, that financial challenge with the reality of the risk reduction, that's also going to drive a bit of a timeline. Now, I think, the race is not to the first of a kind or the fifth of a kind, it's to the 10th or 20th of a kind. And the US should absolutely win that race. Our ambition as Rolls-Royce is to have the US win that race. But it is critical that we do it in a way where the funding comes together and the risk model comes together at the same time.
So in 2035, we'll have gone through how many administrations? And I've been around long enough where I've seen the cycles. I've been in geothermal since 2005, and to try to make a living in geothermal from 2005 was pretty tough until there's been some new technology, like the Fervo energy project in Milford in Utah. But how do you, I've been in first of a kind carbon captures projects, and those are waning now, ethanol's gone. How do you assure I guess a purpose-built contractor like myself that in 2035 there will be projects? I mean, how do we get the administration on board or laws on board to do that?
So you're looking for a 10-year assurance? Okay. No, I mean, I think we're in a different state now. I have a lot of family and friends in the real estate business, and I laugh that, electricity used to be a plug and a spreadsheet, and then we went through a period where everybody's looking under rocks for extra megawatts. We're still sort of in that period, and now you're looking to actually procure your megawatts. I think this time is different because of the pull from the market as opposed to the push from the nuclear nerds about all the other benefits of nuclear. So I think there's durability, there's bipartisanship around nuclear as well, and there's just some attributes why this will have staying power. But I think to Matt's point, 2035 is the probably realistic time frame. I would just encourage us all to be unrealistic in the sense that, it's an industry that has 40 years of ingrained thinking about how to get things done, and it doesn't have to be that way. We've seen it be faster and other stuff. Granted, state-backed can help a lot of things, but I think if you look really creatively at siting, permitting, design, partnerships, I think there's a unique spot right now where if you execute, there's almost limitless access to capital. The types of capital are an interesting mix, but you can do it, and I think you can execute within this decade if you get out of that sort of fixed mindset and start to think about unique ways to approach at least first-of-a-kind projects.
I think one of the other things that particularly states and industry can work together better on is getting a much clearer picture on energy demand. I mean, the reality is infrastructure of any kind takes a while, and 2035 is not an unrealistic market transition kind of time frame. But part of the problem is we have wildly different views of what energy demand is going to do. That hampers state planning, it hampers private investment. The more we know that demand, kind of high, medium, and low, is going to increase for electricity, and not just from hyperscalers, but from other things like electrification of transportation or modernization of manufacturing. If we get a clearer picture of energy demand, someone will win the race, right? Someone will supply it, someone will make the investment. And at that point, then it's kind of an economic competitiveness battle. So I think if we had better forecasting, better and more transparency of how it was built, it would help infrastructure investment generally and help innovation specifically.
Let me just quick clarification for our friends in the media. 2035 notional number, mid-2030s, right? But in terms of, we are not going to move into the US market unless the key enablers are met, including an assurance that the market will be there. We do feel like it's going to be there. And I think part of it is when folks have skin in the game, you're going to get the project across the line. And it's how do you put the skin in the game in the right way? And that's going to fall on us as the OEM to have some skin in the game. It's going to, Secretary Wright has been so aggressive with saying you need to have the right credit of offtake, and that's why we're looking to the hyperscalers. But I think there's things also DoD can be doing, that the U.S. government can be doing as an offtake partner, and states can be doing, right? If you have state assets, bring those to bear from a PPA context. That's just going to, enhance the ability to keep skin in the game and to be a forcing function to allow the monetary aspects of all this to come together.
So a question for Chris and one for Stacy. Chris, you made, and perhaps I'm hypersensitive, but you made a comment about some people were of retirement age and were going to leave the workforce. My question is, are you telling me it's time to go? Or that wasn't personal, that was just in general?
Correct. Yes.
All right. I feel better. I feel better. A quick comment. We've heard several times that we have a workforce problem. The company I'm with funded its first scholarship at the University of Idaho 4 years ago in atomic. And that is going to give us doctors, it's going to give us masters, and it doesn't take a huge amount of money. We've had several candidates writing their thesis, and what they needed was a $5,000 stipend over the summer for them to finish their thesis or their paper. I think industry should respond to this need for workforce development. If you need it, then go develop it. I don't think we need to have 100 government programs. This isn't going to be solved at some master level, in my humble opinion. Stacy, you seem to me to be conflicted. On the one hand, the parts you need for the AP1000 are not able to be sourced domestically. But on the other hand, you have AP1000s being implemented in China. That seems to me difficult to square. Can you explain that?
So China was able to basically build their own supply chain. That's how they solved that problem. They also commit to procuring long lead items very early so that they're on site, reduces final investment decision risk. And we could do a better job of that here. We could commit to long lead procurement items early so that when those items are on site, it makes it easier for the owners to make their final investment decision. And also with respect to the supply chain not necessarily being available here for the AP1000s, we're talking about some specific manufacturing capacities, the large forgings and castings. That type of equipment isn't available here now, but it could be. It could be with the right investments, with the right suppliers. If they see the return on investment, we're seeing over and over again that the suppliers are willing to invest, but they want to ensure that the return on investment is there. They're looking for partnerships, either from the developer, from the OEM, from the utility, from the government. That's what the suppliers are looking for. So I think we can build it here, and we should build it here domestically to support domestic projects. On the Vogtle projects, we did have to source large components from overseas. But that doesn't mean that we have to keep doing that for the next 30, 40, 50, 80 years, for as long as any of these advanced reactor designs are going to be in play.
Thank you. Paul Hughes, State of Kansas. Just kind of borrowing from our conversation yesterday, we were looking at 11 states that were part of a first movers pact, and that caught my attention. And I looked at it closer. 9 of them are east of the Mississippi. And as the state, we have an interest in this industry, and it's the reason we're here. And so we want to solve for we can help solve for this problem on workforce, and we want to. The issue we have is exporting talent, where we're building the talent and it goes somewhere else outside of the state, so that the taxpayers benefit left, because it's a highly mobile workforce. So 2 points and a question. One is that the Western states may be disproportionately disadvantaged when it comes to workforce if all of the opportunities on the East Coast. And I missed my second point, so I'll go straight to the question. So who's doing this the best in your view today? Which states are doing the best job at producing talent? Because when we were digging deeper into the industry, my earlier point, we went to a couple of West Coast companies to meet their teams, only to meet graduates from Wisconsin and K-State. So who's doing the best job of this in the western part of the country?
Can I throw one just on Kansas? So from an aerospace side, think Kansas is among the best in the country at doing a talent development and retention. So what Wichita State has done in partnership, and major credit to Senator Moran for leading a lot of this effort, you have programs that get kids into manufacturing at an early stage before, and then they can, as they're leaving high school, they're in the factory, and then they're doing coursework for a 2-year, 4-year degree in parallel. You have a job in the region, you have academic ties in the region, and you come out with incremental growth in your pay for the students. I don't know anywhere in the U.S., because we haven't built nuclear in for so long, that is doing that. So I think Kansas has, first of all, a wonderful working model for how to build and retain talent in an industry. I think from again, just speaking as Rolls-Royce, where we are, there are the states that can throw money at the problem, Texas being one. I mean, Texas has such significant amounts, orders of magnitude more going to this in the form of grants than other states. There seems to be a way for risk reduction to be implemented there, which then draws contracts that then draws firm workforce development issues. Where I think, though, the West has an advantage is in, again, going back to the demographics challenge. The kids that are going to be staffing these plants from mid-2030s to 2050 are young age right now, and we have some of the youngest demographic states in the country in this room, Utah being top of that list. So I think if you can leverage that wave of demography well, West has an advantage in putting that together. But I couldn't tell you, I don't think we are at a place right now where we've got any working examples, because we just haven't built nuclear at capacity in this country last decade plus.
I think from a state perspective, you look at it, right? Economists think labor is mobile, because it is, but most labor doesn't want to be mobile, right? And so at the end of the day, you have to provide the opportunity for somebody to stay where they are. And so the states that do this best right now are the ones who have had nuclear for a long time. If you look at the concentration of operating reactors, but also supply chain pieces in the fuel supply, it's concentrated on the East Coast and in Washington State. Washington State does great around this stuff because they've had the historical DNA. But if a state can create opportunity, and I'm a bit biased, but I also think it's for good reason, because they are generally more labor intensive, is if you can get the supply chain pieces for nuclear, not just fuel, but also pipes, parts, valves, there's just more opportunity to stay where you were grown, raised, rooted, educated. And that's how states are going to do this well moving into the future.
Thanks for all of your insight. I have one suggestion, because there's a lot of interest in this room, keeps coming up. The students that are in middle school and high school right now, question is how to get them into this ecosystem. Show them. Take them on field trips. Bring people to the schools. On my time, I go and visit every high school that will have me in my area to talk about nuclear energy and energy in general. And then students have an idea. Their worldview is what they've experienced. Westinghouse has a program where they bring students every year to their Waltz Mill site and shows them around. And at Waltz Mill, they build things, they test things. You can show them opportunities for what skilled labor looks like, what engineers do, what managers do, and they get that experience and they see themselves in that job in the future. The second thing for the supply chain for the panel, traceability is a challenge for parts and components, and it's one of the QC issues for the supply chain. What are your views on the actual benefit of moving to ISO 9001, which most suppliers are already qualified for, instead of pure traceability for parts? Traceability, for the folks in the room that don't know it, you have to follow from the mineral, the mine, all the way to the part where it's installed. You have to keep tags or stamps on that material at every step. And that adds overhead, but it also adds another quality control program you have to have, even if the bolt is the exact same as the one you would sell in Home Depot.
Well, I'll jump in. Tracking and tracing is going to be an essential part of providing appropriate security. There are approaches to tracking through essentially advanced manufacturing type approaches, using standardized certification processes. It's coming. We need to get ready for it. I wouldn't necessarily pick a winner. Let's use this particular process, but we need to just recognize it's going to be here, and there are ways to do it. And the more that we standardize the way that it's done, the better off we will all be building a supply chain that is appropriately secure. I think you can look again, let's just talk about modernization of the grid as a whole. There's been huge concern about security and tracking and creating responsibility all the way down the supply chain. It's not going to be any different the expansion of nuclear. So we just need to get ready for it. But I'm not going to pick any more than I'm going to pick my favorite child, right?
Great. Please join me in thanking our panelists. Thank you all so much for being here. We're going to take a very short break while we transition our folks for our next panel.